Hi guys, so we learned in the last lesson about virtualization, so server virtualization, and I told you some of the great benefits of using virtualization. But it's not the end game, so there are other technologies that have come along since virtualization that also give us some great advantages. And one of those is called Docker containers. So let's have a look and compare virtualization with containers. So we're looking here at what we saw in the last lesson. So we have a server with a hypervisor and a virtual machine running on top. So what's the issue with this? Well, you know what the advantages are, but there are some limitations. So every virtual machine needs an operating system. So remember, we can have many virtual machines running on one physical server. And each of those is going to have an operating system. That could be Windows or Linux or some other operating system. Now, operating systems do use quite a bit of resources, so they need quite a bit of CPU and RAM. There's quite a bit of file storage needed, so they need a fair amount of disk space as well. So there's quite a lot of overhead required for every individual virtual machine on your physical server. Now, in the container world, the architecture is slightly different. So we have the server, we then have an operating system. Again, the example is Windows, doesn't have to be Windows. And then on top of that, we run something called the Docker engine. Now, there are other examples, but Docker is one which is very well known. It's probably the most well-known containerization platform there is. So the Docker engine runs on top of Windows. So we've got one instance of Windows here. And on top of that, we can then create what are called containers. So a container actually includes all the code, the settings, and the dependencies for running an application. So the icon here is for Java, so this is a Java application. We then might have a web application, maybe this is Nginx or Apache. And we've then got a Python application running as well. So each container is isolated from other containers. So even though they're essentially using the underlying operating system, they are completely isolated from each other, just like a virtual machine is. So they can't see each other's resources. They don't have dependencies on each other. Everything that each one of these individual containers needs to run is included. And you can run all these different types of application. We've got a .NET application, another Java application. This is an Nginx application, and so on. And another key advantage of containers is they can start really quickly. So remember, operating systems can take a bit of time to boot. So whenever you start up your computer, your Windows operating system or your Linux operating system has to load the files into memory, has to start up a bunch of services and processes, and that can take quite a bit of time. But a container doesn't have to start the operating system. So it's super quick. They can be up in a matter of seconds. Another advantage is they're really resource efficient. So again, you don't have multiple instances of your underlying operating system on this particular server. So the container only needs the memory required to run the actual application itself. So all that overhead is gone. So if you have 20 containers running on a server, you've still only got one operating system here. Whereas with virtualization, you've got 20 operating systems running on top of your hypervisor. So that's a lot more resources used for the operating system. So containers have really exploded in popularity over the last several years. Docker is definitely the most well-known implementation. Another one which does some management of the containers is Kubernetes. So you might well have heard of Kubernetes as well. And those are two of the major technology players in this space.